Let's head over to Vladimir to learn more about how to secure our web applications with Sqreen.
Thanks so much for the intro, and welcome to my talk. So my name is Vladimir. I'm a software engineer in a startup named Sqreen. You can follow me on Twitter at PaulDefet. That's probably the preferred way to contact me. Also, a couple words about Sqreen. We are an application security company. So we provide you with a package that you add in your application and that will inject security algorithms into your applications to prevent certain attacks, such as injections. What are injections? Glad you ask. That's partially the content of this talk. This talk is entitled, "It's dangerous to go alone, take this bit of application security." And the goal is actually to give you the basics of web application security in the context of a Strapi application. So let's talk a bit about the OWASP Top 10. The OWASP Top 10 is created by the OWASP. The OWASP stands for the Open Web Application Security Project. It was created in 2001, and that's a non-profit which goal is to actually help leveling up on application security, on web application security. So they've got a lot of resources on their website and a lot of projects. And if you're interested in taking your career to a whole new level in terms of application security, you can either go to the OWASP or check my course online on InfoSec skills, but that's probably not the topic of that talk. So regularly, they publish what's called the OWASP Top 10, which is the top 10 threat vulnerabilities that actually threaten web applications. They put it up to date from time to time because it's data-driven. So for instance, recently, Sqreen was asked about providing data about the amount and the kind of vulnerabilities we have seen in our customers without disclosing any secrets, of course, and to let them know about what vulnerabilities are the more prominent based on our data set. So the last version was published in 2017. That's supposed to be a 2020 version, but it got a bit late, and hopefully it will be released this year. This is globally recognized by developers as a first step toward more secure coding. And if you master the OWASP Top 10, it doesn't mean that you will never have vulnerabilities. It just means that you are ready for the top 10 most usual and critical vulnerability against a web application. So what's inside this top 10? And let's do a YouTube-like video, with top 10 reasons why your application might be pwned by an evil hacker. No, I'm kidding. It's not that bad. And let's go through the top 10 with the context of a Strapi application. So there are 10 elements in the OWASP Top 10. The first one, named A1, is injection. The second one is broken authentication. Third one is sensitive data exposure. The fourth one, XML external entities, most known as XXE. Then we've got broken access control, security misconfiguration, XSS for cross-site scripting, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. And for each of these items, we will actually question what is their impact in a Strapi/Node.js application. So let's remove two quick wins. First of all, we can remove XXE. XXE only happens when you handle XML. And if you're familiar with XML, you know that you can actually link to another document. It would be the equivalent of injecting an iframe in a web application of some kind. Well, usually to get an XXE, you need an endpoint that accepts arbitrary XML. And you need that your XML parser allows the loading of external entities either on the local hard drive or from a remote place. And you would just put a link in the document and hope that when being parsed by the XML parser, it will load the external entities. Well, as far as I know, Strapi does not have any default support for XML, and also across all XML handling engine in JavaScript, in Node.js that I've been through, only one was vulnerable to XXC and not by default. So you had to tune it to enable XXC being vulnerable on it. So let's put XXC on the side, and given the length of this talk, that's a quick win. Second one we will remove is insecure deserialization. So insecure deserialization happens when someone is able to execute arbitrary code when data is deserialized from the network in the application server. This can happen a lot in PHP, for instance. There are some cases in Java, if I'm not mistaken, but 99.9% of the time in Node.js, when you deserialize something, you deserialize a JSON object. And apart from prototype pollution that requires more than the deserialization, there are no much risks with JSON parsing. The only risks that can really happen with JSON parsing is the same one that with GraphQL expressions, is that if your GraphQL query or your JSON string is way too big, it can take a lot of time to deserialize for the application, and since Node.js is single-threaded, that would block the event loop and provide the attacker with a short-timed denial of service. But that's most of the time okay, and that's actually really, really, really rare in Node.js/Strapi applications. Okay, so we removed 2 quick wins. Yeah, else, let's move to A1, injections. So there are multiple kinds of injections that are possible in a web application. The first one would be obviously database injection. So I hope you are familiar with SQL injections. They happen when an attacker is able to run arbitrary SQL code on your applications from a remote point through an HTTP request, for instance. And the thing is, by default, in Strapi, you would be probably using the Bookshelf ORM if you are using SQL. So in that case, you are mostly safe. I don't say that Bookshelf is always safe against SQL injections. There have been vulnerabilities in other ORMs, but most of the time using an ORM fixes SQL injections issues. Just make sure you never use next.row with Bookshelf, because it will actually open the door to SQL injections. So never build row queries, and if you do, well, learn about SQL injections and how to protect them with prepared statements. But as a rule of thumb, never using next.row should put you in a very good spot in terms of security. Also, if you're using MongoDB, there's what's called MongoDB injections. You can check my other talks, just Google me about that topic, and Mongoose actually does not prevent any of them. What happens for a MongoDB injection is when you have an object coming from the user, for instance, through a HTTP request, and it contains MongoDB operators that will be executed and change the meaning of the MongoDB query that you had coded into your app. Sorry about that. So you don't want to pass objects directly from the HTTP request, from the body, from the query string to the MongoDB driver. And if you do that, well, enforce data validation, so you are sure that the shape of the object is the one you expect and comply with your data model. And if you do that, you should be good. You should be pretty much good with SQL injections. There are also OS injection, operating system injections, and basically just run away from child process. If you end up importing child process in your application, you're probably in danger, so stay away from it. And if you have to use it, never use anything from the HTTP requests inside it. HTTP including the GraphQL query. And if you really need to do that, to start a child process with remote user-defined parameters, then you need to use the spawn method, not the exec, not exec file, not fork, spawn method, and make sure that you provide these parameters from HTTP as arguments, not as the executable part. That should take you to a good level of safety, but overall, avoid this module altogether, especially with inputs. The last kind of injection I wanted to discuss here was directory traversal or file access injections. Well, basically, that's when you open a file with part of the path coming from the HTTP request. And that means that the user might be able, if the application is not safe enough, might be able to read arbitrary files on the disk. And you don't want to do that. So never open a file based on HTTP inputs without making sure that this actually resolves to the right file to open. And you can use the method path.resolve in the Node.js standard library to make sure that the path opens the right thing you want to allow it. If you've got a public folder, make sure that you never open a file that is outside of this folder. In other words, data validation, data validation, data validation. And an easy way to do that in Strapi is to create data validation services, and that makes sure that objects have the right form, paths are properly done. Just do that. Provide a data validation service in your application and use that. And do not trust inputs. Do not trust your users. Always validate, sanitize, and double check anything coming from the user. And don't trust things that are already in your database. You may have path injections into the database, XSS, SQL injections from a query to another. Don't trust anything that is not hard-coded in your source code, basically. Data can be tampered with. Okay, we're done with injections, and we still have 10 solid minutes of talk, so we are on a good train. Broken authentication. Well, don't reinvent the wheel. Broken authentication happens when you miss something on the authentication flow and you create vulnerabilities on this part of your app. Don't reinvent the wheel. Strapi provides authentication primitives. If your customer, if your user are only going to be web browser, well, use HTTP only, same site, secure cookies. HTTP only will make the cookie inaccessible from front-end JavaScript code, meaning that if there is a malicious script running on the browser, well, it won't be able to exfiltrate the cookie to a third party. Same site, make sure that your cookie is not accessible from another domain so nobody can steal it by doing some shenanigans around that. Secure, make sure that your cookie is only transferred over HTTPS. You don't want your cookies to be allowed over HTTP. Signed? Well, you can sign your cookie to make sure that they have been issued by yourself. But if you use a GWT as a cookie, and I said a GWT, not a GWT token, because the T in GWT already stands for token, if you use a GWT, well, it's already signed. So you don't need to sign a cookie that is already signed. So you're good with that. Logout. That's actually a business decision. And if you need a logout flow, if you have one, you must make sure that the cookie or the GWT is invalidated. So there is a defined field in the GWT specification for an ID for your token. And what I recommend to do is to use two properties of the GWT. First one, you can put an expiration date in a JSON Web Token. In that case, well, if your token has an expiration date and an ID, you just need a Redis store that stores the ID of invalidated tokens until they are invalidated because they are too old. There's actually a way in Redis to time out data. So just do that. Have an expiration date and an ID and store the list of invalidated tokens until they are out of date. And you should be good. That's basically reading the JWT specification. I know it's a RFC, so it can be scary, but it's actually very readable. If you check my old blog on Medium, you might be able to find an analysis of the specification. Okay, that's it for broken authentication. Let's move to A3, sensitive data exposure. Well, we are in a post-GDPR, CPA, and other specification. I read that India has created a specification, a legislative ground for PIIs, and same thing for Russia and China. So first of all, know the legal framework of the space you operate in. If you are to store personal identifiable information, also known as PII, or personal health information, known as PHI, well, know about the legislation in the space you operate. That includes email address, full names, addresses, date of birth, social security number, all those kind of things. And audit the content of your database. Know what kind of assets there is in your database, and you need to be able to track them. Audit the application. Make sure that the database passwords are safe, that there are no API keys that can be found. Make sure that all of this can't leave the application without proper client identification. And it's not about authentication. It's not about knowing if someone is logged in. It's about making sure that the client getting these pieces of information is what they claim they are. That's why on GitHub, for some operation, they will ask you to type your password, to recheck your identity, even if you're already logged in. So make sure that you know who accesses which pieces of information. Okay, broken access control. Well, it's about access control. It's about preventing user A to access the data of user B, or an arbitrary user to delete posts on a forum, which is a power usually only granted to moderators and administrators. Do not reinvent the wheel. Strapi provides role and permissions out of the box. Use that, but also make sure the right resources are gated properly. So maybe the role-based access control is enough for you, but there might also be needs for resource-based access control, making sure that student A does not have access to the grades of student B. That's something that you need to prevent. And if you need to make sure about the data being owned by the right person before sending it back, yes, please do. But also make sure it's about all the traits of the resource. If you remember the previous one, it's about sensitive data exposure. So maybe some users have access to customer records, but they should not have access to personal mail address or banking details or social security numbers. So you want to make sure for each piece of information in an entity that it's actually accessible by the customer. So make sure you know who accesses what. Security misconfiguration. Well, you use libraries, you use tools, don't make mistakes when configuring them. I know this one is terrible to say. So do not use weak password for admin accounts. Never. And hopefully don't name them admin. Enforce HTTPS with a strong cipher, and it's even better if you don't have to handle it, if your hosting provider handles that for you. When you connect to a remote database, use an encrypted protocol. So if you're using MongoDB, for instance, it's as hard as adding $SSL equals true. Same thing for Postgre. You want to make sure that the communication from your app to the database is either happening locally and can be in drops, so on the same physical machine, or encrypted over the network, so nobody can eavesdrop what's happening. Do not use default weak known credentials. That one is actually very important. And that's actually also qualifies for your own development machine. So by default, MongoDB does not have any password or credentials when you create a database. And by default, a lot of people use stupid password and a username for their root admin locally for MySQL or Postgre. On the network, it's terribly dangerous, and a lot of databases have been attacked that way. But on your developer's desktop or laptop, it's actually disastrous too. Mostly with your laptop. Let's say you are on a shared Wi-Fi in a Starbucks, in a hotel, in an airport, or even at the office. Well, if you've got this kind of services and you don't have a firewall preventing people from the outside connecting to the local MySQL, to the local Mongo, to the local Postgre on your machine, well, they can connect. And if you use weak password or no authentication, they can connect. And with these databases, sometimes it is possible to run arbitrary script on the operating system. So you're basically opening a shell for anyone to use on the local network. Meaning, okay, if you see me like that in a McDonald's sitting next to you, you probably want to run away. But not all hackers have a hoodie. So it's hard to recognize us. Just, be careful with that. And make sure that static assets are in a single directory and you don't serve anything else. Configure your web server for not serving anything else. Do not expose interfaces you don't use. GraphQL, for instance, that will give an entry point for someone, an entry point that you don't monitor. Okay, XSS, cross-site scripting. As far as I know, Strapi's interface is pen tested. So cross-site scripting happens when someone is able to run arbitrary JavaScript on your web browser. And since Strapi's interface is pen tested, there should not be emphasis on the should. But what about your custom frontend? Well, make sure you don't use unsafe methods for rendering. If you're using React, as far as I know, the only XSS vulnerable method apart from unknown vulnerabilities, is dangerously set in our HTML, and its name actually should scare you enough for you not to use it. If you're not using React, just make sure you're never using inner HTML, outer HTML. That's for when you render your page on the browser side, because the document object model, the DOM, has a way to update the content without creating new nodes. When you change inner text of a node, well, you can change its content without being XSS vulnerable. However, when you do server-side rendering, well, you just return a string. Even if you do component rendering, you just return a string to the web application to use as a piece of DOM. So when you do server-side rendering, you are probably vulnerable to XSS. You want to escape everything. Everything that comes from the user, everything that comes from the database. Take a DOM Purify library. It's really, really good. And escape everything. Do not trust anyone or anything. In other words, do not trust data coming from any store, Strapi, browser store, other API. If it doesn't come from your source code, it's probably malicious. Not probably, but it might be malicious when rendering a page, browser or server-side. And it's actually 10 times more dangerous server-side because there is no good way to protect yourself. If you're really interested into XSS, you can check what trusted types is, or my latest class about secure JavaScript programming and infosec skills. Okay, let's run a bit. We've got 5 more minutes. Using components with known vulnerabilities. Well, you've got companies that have databases of package and vulnerabilities. They don't find vulnerabilities in their database when you run Snyk or Google or npm audit, not Google, GitHub security bot. They don't find vulnerabilities. They just have a database of this dependency in this version is vulnerable. And they just use that. Name your champion, GitHub, npm audit, Snyk. Use the one you want, but you must use one of them. You have to. Last but not least, insufficient logging and monitoring. Always start with the question, what could go wrong? We are talking about checking who accesses data. Maybe you want to log when a user accesses private information. What could go wrong? Log what you need to reproduce bugs, but make sure that you don't leak sensitive data through your logs. That's actually a very bad practice. And a few years ago, a very, very big social network, Blue One, had actually email address leaked into logs. So make sure that does not happen for you. Monitor your production with an APM, so you know what the performance of your application is, Datadog for instance, so you are not vulnerable to denial of service if you've got bad performances. And use a security monitoring tool. That's why you probably want to install Sqreen for the moment, but maybe there will be some changes in that space with Sqreen. Just Google our the news about us, and you will see that I did not recommend using Datadog by mistake. And here we are for the OWASP Top 10. Congratulations for keeping an eye on this presentation all that long. I know it was a bit long. Let me go away with a few takeaways for you. Do absolutely not trust user-issued data. Read the Strapi documentation in depth so you don't reinvent the wheel. All regular web applications still make sense here. If you learn something doing PHP or Java, it still makes sense. Learn from the OWASP. Check my talks about Node Security Talk. Feel free to contact me if you want a discount code for my online courses, Secure Node.js Programming and Secure JavaScript Programming. And of course, use Sqreen. Sqreen now supports Koa, it's in beta, and Strapi is based on Koa, meaning that Sqreen can beta support Strapi applications. So try it. Just do npm install save Sqreen and check our documentation on how to enable the beta support for Koa. We'll be really excited to get your feedback and opinions on the product, and we will protect you against a lot of the items from the OWASP Top 10. Thanks again. Once again, I'm Vladimir the Turkem. I've got commit rights on Node.js. I'm responsible for the Node.js security as a project, and I'm a security software engineer at Sqreen. Contact and follow me on Twitter at Paul Defet. Have a great rest of the conference. It was amazing spending this time with you.
Thank you, Vladimir, for that awesome talk. Security is a huge pain point, especially coming from the world of PHP. With projects like WordPress, I've had my own fair share of hacked websites due to broken plugins, insecure themes, and SQL injection. So it's great to see Strapi has a 9.9 level security, as long as you play by the rules. Hackers trying to access your project can move on,